This is our beautiful planet. But after a nuclear war, it might look like this, with clouds of smoke covering it, blocking out the sun, and making it cold and dark at the Earth's surface. The way it would happen is that nuclear weapons are targeted either at cities, and that would cause fires, and the fires would burn, and the smoke would go up in the atmosphere, and the smoke would absorb the sunlight, and that's what would make it cold. If you target missile silos, you get dust up in the atmosphere. In both cases, they prevent sunlight from reaching the ground, and that means it gets cold, and that could be devastation to our food supply if there's enough smoke and if it gets cold enough. What determines how cold it gets is how much smoke, and that's determined by how many weapons and where they're directed. Absorbing the sunlight also heats the atmosphere, the upper atmosphere, and it turns out that destroys ozone in the stratosphere, and that lets a lot more ultraviolet radiation through the surface. That's also not good for us or for plants. So if there's enough smoke, we can get nuclear winter. The temperatures can get below freezing at the surface of the Earth, even in the summertime, and we wouldn't be able to grow any food. It would not only get cold, but it would get dark, there would be less sunlight, there'd be less rain, so it would be dry, and more ultraviolet radiation. So here's a graph showing the number of nuclear weapons on the planet. Started off with 0, then the first nuclear war, we dropped bombs on Hiroshima and Nagasaki, and then the US arsenal started going up, the Russian arsenal started going up, and in the mid-1980s there were 70,000 nuclear weapons on the planet. Then the arms race ended, and the number of weapons started coming down. And the work on nuclear winter, the warning that we gave the world in the 1980s, was part of the story of why the arms race ended. As you mentioned, SANE, there were also lots of demonstrations against nuclear weapons at the time, and that was also an important part of the story. What would be the effects of nuclear war? There'd be fires after a nuclear war. And the smoke might cause climate change. We'd had nuclear weapons for almost 40 years and nobody had thought about that. The next year, a Russian group and an American group both calculated what would be the climate change. And their answers agreed. And the next year, I did a calculation also, and then the arms race ended. So I assert that that was part of the story. Now, I'm a scientist, so when I do research, I analyze data, I run simulations with computers, but historians don't do that. They just ask people, okay? So that's the evidence. And the two people that ended the arms race were Mikhail Gorbachev and Ronald Reagan. So, by the way, the Soviet Union ended 5 years later, so it wasn't the end of the Soviet Union that ended the arms race. The arms race was already over. And you might be happy the number of weapons is going down, but it's still not 0. There's still 5,000 nuclear weapons on the planet that will be deployed at the end of this year, and that's still way too many. So Ronald Reagan was asked about this, and in a New York Times interview, he said, a great many reputable scientists, Ronald Reagan called me reputable, are telling us that such a war could just end up in no victory for anyone because we would wipe out the Earth as we know it. If you think back to natural calamities back in the last century, in the 1800s, volcanoes, we saw the weather so change there was snow in July in many temperate countries. And they call it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with the whole nuclear exchange, the nuclear winter? It's possible. And Gorbachev said, models made by Russian and American scientists showed that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. Knowledge of that was a great stimulus to us to act in that situation. So, that was 35 years ago. Why am I even bringing it up now? So I want to ask two questions. The Cold War, the nuclear arms race are over. Could the remaining nuclear arsenals still produce nuclear winter? Could they make so much smoke that the temperatures would go below freezing and kill all the crops in the summertime? And the second question, does anybody know how many countries there are now with nuclear weapons? 9, very good. There's 9. And so it's not just the US and Russia. What if 2 of these new countries had a nuclear war? What would be the impacts of that? That's the other question we want to ask. So I'll tell you the answer. Yes, we can still produce nuclear winter, and it would last much longer than before. The supercomputers that we used for doing calculations in the 1980s, the Cray supercomputer, was much less powerful than your iPhone. So you're carrying a supercomputer around in your pocket, and they couldn't do very long simulations. They couldn't model the entire atmosphere. Now, with modern computers, in fact, some of the simulations I did up the street here at the NASA Goddard Institute for Space Studies up at Columbia, and we learned that the smoke would go up in the atmosphere and last for many years because we can include that part of the system that we couldn't do in the 1980s. Now, if two small countries had a war using less than 1% of the nuclear arsenal, it wouldn't be nuclear winter. That is, the temperatures wouldn't get below freezing, but it would still be large climate change. Of course, the direct effects would be devastating, but it could still produce impacts on global agriculture for more than a decade. So now I'm going to tell you how I got these answers. First of all, what does a nuclear weapon do? We used to test them in the atmosphere. This is from a test in the Nevada desert. You see the distinguished generals have their fingers in their ears and sunglasses on and lit by the bomb. It's like bringing a piece of the sun to the earth for a fraction of a second, and everything within a certain radius just bursts into flames. And it's the fires, it's the smoke from the fires that causes the climate change. So they built this house there to see what would happen. And as the fireball rises, the house bursts into flames, and then the blast wave hits like thunder following lightning and begins to blow it apart. And you might say, well, it's going to blow out the flames, but it's also going to break the gas mains, it's going to break the electric lines, and so you can imagine fires continuing to burn. Now, it matters what kind of smoke you get. If you burn something that's made from petroleum, oil-based, then it has this black sooty smoke, which is very effective at causing, at absorbing sunlight. So this linoleum tile here is probably plastic, the chairs you're sitting in. And so we would go into buildings and say, how much material is there and how much would burn? Wood burns with a lighter colored smoke. It's not as effective. This is from the 1992 Gulf War. You can see what the smoke looks like. So we've had a nuclear war. The US dropped 2 atomic bombs on Japan. In Hiroshima, on August 6th, 1945, they dropped this 15 kiloton bomb. That's the explosive power of 15,000 tons of TNT. You might have heard about this Moab, the mother of all bombs that they dropped on Afghanistan a few weeks ago. That was 11 tons of TNT. This is 15,000 tons. This is 1,000 times more powerful than that bomb, but it's still a small nuclear weapon by today's standards. Now, as I showed you, we've been reducing our arsenal, but our current arsenal is still so powerful. If you dropped a Hiroshima bomb every 2 hours, starting on August 6, 1945, 12 times a day for more than 70 years, you still couldn't use up our current arsenal. The plane that dropped it was this B-29 Superfortress that was invented for World War II. It could fly at 30,000 feet. It was pressurized. And it was called the Enola Gay, named after the mother of Paul Tibbets, the pilot. And you can, I saw it first in a warehouse at the Smithsonian. That's the front half and the back half. This is a mock-up of the bomb. Now you can go to the Smithsonian Museum Annex out by Dulles Airport in Washington and see the actual plane. The bombardier would sit here in the front. Here's a drawing of what it looked like when it dropped the atomic bomb. And this is what one of the survivors of Hiroshima remembers. It's the fires and the smoke. And it's the smoke, as horrible as the direct effects were. 150,000 people were killed by the blast and the fires and the radioactivity. The smoke then went up into the atmosphere. This is what Hiroshima looked like afterwards. All the buildings were burned. This is what Nagasaki looked like after the bombing there 3 days later. And it's not, unfortunately, we have examples that cities can burn. That's one of the questions, do cities really burn? In 1906, there was an earthquake in San Francisco, and it started a fire, and it broke the water main, and Jack London was sitting out on the bay and wrote about it. He said, I watched the vast conflagration from out on the bay. It was dead calm, not a flicker of wind stirred. Yet from every side wind was pouring in upon the doomed city, east, west, north, and south. Strong winds were blowing upon the doomed city. The heated air rising made an enormous suck. So it was a firestorm, and it just sucked the smoke up into the atmosphere. And this is what San Francisco looked like afterwards. Some of the stone buildings were still there. One of the first aerial photos from a series of kites. Now, there's 15,000 nuclear weapons now if you count the ones that are on a shelf waiting to be put away. This is the American arsenal, this is the Russian arsenal, so these gray ones are ones waiting to be dismantled. And this is the other 7 countries. So now you might ask yourself, why do the US and Russia have 7,000 weapons when every other country has chosen to have a couple hundred? China could build as many as they want, so could France, so could England. Lots of countries could build them, and they've chosen the number to be 0. How many weapons do you have to put on your enemy to deter them on their capital city? How many atomic bombs do you have to put on their capital city to deter them? 1. Okay, so maybe you need 2. The first one doesn't work, but we've got thousands. Why don't we get down to 200 as a first step? So India has about 100, Pakistan has 130, and North Korea maybe 10. Does anybody know what this is? It's a picture taken from the space station.
North Korea?
No, because there's lights on both sides, all over the place. North Korea is pretty dark from space. This is the only border you can see from space. It's got lights all along this fence. No. This is India, Pakistan, Afghanistan. That's Karachi. So this is the Indus River Valley where most people in Pakistan live. This is the place, probably the most dangerous place where a nuclear war might start. In Kashmir, the Himalayan mountains are up here. In Kashmir here, there's always skirmishes along the border. And both of these countries have nuclear weapons. So we asked the question, what would happen if India and Pakistan had a nuclear war? What would that do to the climate? So you can imagine some skirmish escalating due to poor communication, panic, fear, misunderstanding. So, you read these all the time. This was in the New York Times. There was a skirmish along the border. Indian troops fired on a bus, killing 9 passengers. The Pakistani retaliated, killing 7 Indian soldiers, so 19 people were killed on the border. Next week, there was another thing like that. So we've been really lucky that this hasn't escalated yet into a nuclear war. Remember the hotel in Mumbai that was invaded by Pakistani terrorists and they killed about 100 people? That didn't start a nuclear war. What about this? Imagine you're Pakistani air defense and you see this invasion coming into your country. The stealth technology doesn't work perfectly. Who would you think was invading? Could this have started a nuclear war? Did the US even think about that when they went in to kill Osama bin Laden? Well, as you know, it didn't, but. So we said, okay, they've each got 100. What if they took 50 weapons? Now they've got a little more than 100. What if they took 50 and put them on targets in each of the other countries, the places that would burn the most smoke? And so 50 nuclear weapons on India would produce 3.5 million tons of smoke. And 50 on Pakistan would produce 3 million tons of smoke. So 3 and 3.5, 6.5 million tons of smoke. So we said, let's simulate. My friend Brian Toon said, I was surprised how much smoke there would be, and this was like 10 years ago. I said, who's going to calculate the climate response? Well, we thought maybe you would, so my student and I did, and we said, let's be conservative. Let's just do 5 million tons, so maybe 85 atomic bombs. And we decided to use 15 kiloton weapons. So the same size that were dropped on Hiroshima, very small by today's standards. Nowadays you can make them bigger. We don't know how big the ones are in India or Pakistan, but so we decided to be conservative, use the small ones, and use the same radius, 13 square kilometers, same area that burned in Hiroshima and burning these cities. But they're modern megacities, so they've got more fuel in them, and we calculated how much smoke would go up into the atmosphere. So 5 million tons, 20 million people would die, it would be horrible. And the horror of the direct effects so far have stopped crazy people from using them. So here's a movie of where the smoke went. So we put it in the atmosphere over India and Pakistan, and it blows around the world. And this is the tropopause. We live in the bottom part of the atmosphere where there's rain and weather, but in the stratosphere there's no rain and weather. So pretty soon, after a few days, I'll start over. You can see the smoke after a couple days is heated by the sun and lofted up into the stratosphere. And then it's away from the area where rain can wash it out, and it lasts for many years. We discovered that when we did the simulation. Nobody knew that it would last for that long. And so I plotted on this graph of global warming that I spent a lot of time working on, and this is how the global average temperature would change. So these are degrees Celsius, so it would be about 2.5, 3 degrees Fahrenheit colder than normal. It wouldn't be nuclear winter, it wouldn't be below freezing, but this would be instant climate change. And it would be climate change unprecedented in recorded human history. It would be colder than the Little Ice Age, colder than anything that we've ever experienced in our history. Now, we use the NASA climate model, but people say, climate models are imperfect, so maybe we should make sure it's right. So two other groups have done the same calculation with different climate models and got basically the same answer. All three find global cooling for more than a decade, unprecedented in recorded human history, from much less than 1% of the current global nuclear arsenal. The group at NCAR, at the National Center for Atmospheric Research, has better graphics, so I'll show you this movie. The troposphere, the stratosphere, it's heated by the sun, lofted up here, 30 miles high, and this is in the Northern Hemisphere summer, and it stays up there, and it lasts for more than a decade. And then as it goes to summer in the Southern Hemisphere, the sun heats it from there, it stays up there, but it's only a little bit actually leaves the atmosphere. And so we plotted how much smoke there would be, this is 10 years, from each of these three simulations, how much sunlight would be reduced, how the temperature would be reduced, and how precipitation would be reduced. So temperature would go down 1.5 degrees, global average temperature, but the ocean doesn't warm and cool as fast as the land. So over land you would get more cooling. The upper atmosphere would get heated. The soot is absorbing the sunlight. Temperatures would be 100 degrees warmer, and that's what destroys the ozone. We now worry about the ozone hole over Antarctica, an area where the ozone concentration is low and it lets UV through. Now we'd have a global ozone hole. We'd have UV coming down everywhere. Even though there's smoke, more UV would come down. And what would that do? So it would cause skin cancer, sunburn, it would affect crops in terms of the plant height, it would disrupt the beneficial soil bacteria, it would cause genetic damage over generations, it would make the plants more susceptible to attack by insects, and it would affect the fisheries too, the little bugs that live at the surface of the ocean that are the source of the oceanic food chain. Nobody's analyzed this, nobody's ever done that. Now fortunately, I was just the recipient of a big grant, $3 million, to study this over the next 3 years. We have a big team getting together, and one of the things we're going to do is look at all these in detail. So we're just starting to do this in much more detail. And it was from a private foundation because I couldn't get any money from the federal government. I think maybe Trump scared them. That sort of helped me. So now we did calculate how the growing season shortened. So a growing season is the time from the last frost of the spring to the first frost of the fall. And that gets shorter as it gets colder. So the crops would have less time to grow, they would be growing at a colder temperature, they would have less precipitation, and we calculated how the crops would change based on this. We didn't include the effects of UV yet, just the effects of climate change. And we did it for models that calculate how crops grow in the US and in China. So for the first 5 years, from a little war on the other side of the world using less than 1% of the global arsenal, food production will go down by 20 to 40% for 5 years. So you can imagine how devastating that would be. Rich people like us can go to Zabar's and spend a little bit more money, but people who are just living in marginal existence, they might starve to death because they wouldn't get any food at all. You can just remember in 2010 when there was a drought and heat wave in Russia and their wheat crop went way down, they just stopped exporting wheat. And the price of food doubled, and that was the beginning of the Arab Spring. So because they're in Syria, Tunisia, and so small disruptions of food supply already can cause large disruptions. This would be much larger than that. Even after the second 5 years, 10 or 20% less food produced. But it's much worse than that. I've told you the good part so far. It's much worse than that. This is a Trident nuclear submarine. It has 100 nuclear weapons. But they aren't these small Hiroshima size. They're 100 or 500 kilotons explosive power. So one of these has the explosive power of 1,000 Hiroshimas. So far I showed you an experiment where we calculated the effect of 100 Hiroshimas. One of these has 1,000 Hiroshimas. We have 14 of them. That's 14,000. This is half of our nuclear arsenal. That's 28,000 Hiroshimas. Russia's got the same size. That's 56,000 Hiroshimas. So I showed you the effect of 100 Hiroshimas. What about 56,000 Hiroshimas? We can still do that today. So we decided to calculate, so far I showed you 5 million tons of smoke. What about 50 or 150 million tons of smoke? What could produce 150 teragrams or million tons of smoke? That was a standard nuclear winter scenario we used 30 years ago. In that exercise, we said, let's take a third of the US arsenal, a third of the Russian arsenal, and put it on all the targets in each country. So we went back and did that, and there was still this huge pile of weapons there. Okay, let's put 2 on everyone in case the first one doesn't work. Still this huge pile. It turned out they were put 9 bombs on every possible target, bouncing the rubble. That was a third of the arsenal back then. That's how much overkill we had. So today, if you put 1 on each of the targets, you can still get the same amount of smoke, 150 million tons of smoke. Now, what if the United States attacked Russia and Russia didn't do anything? We just got the fires there. So we looked at 50 million tons of smoke, a third of that too. What would be the effects of that? So now you get this much thicker cloud of smoke. Again, it would cover the world and last for more than a decade. And we looked at how the temperature would change a year later, and these are degrees Celsius. So this is 50 degrees, 60, 70 degrees Fahrenheit colder than normal in the summertime. So let's take a place in the Ukraine where the Russians grow their wheat. And this is a graph of the minimum temperature. The 0 is freezing. So in a normal year, it gets warm up to 70, 75 degrees in the summer, below freezing in the winter. But the red is when we put all this smoke in the atmosphere. The temperature plummets below freezing. And even the next year, it's still below freezing. You can't possibly do any agriculture if the temperature is below freezing for 2 years. That really is nuclear winter. So one of the questions was, using these very simple climate models in the past, was nuclear winter theory correct? And it was. And we plotted how the temperature would change. Before I showed you this diagram, now I'm showing you this. I had to rescale it. And if we plot it on the global warming curve, now I've got to rescale it again. 18,000 years ago, when there was an ice age, the height of the ice age, when ice sheets were covering North America and Europe, the global average temperature is about 5 degrees Celsius below normal. So we're going to produce a nuclear ice age instantaneously from this, or very close to it if we put in a third the amount. So what's new about this work? A nuclear war between any nuclear states using much less than 1% of the current arsenal could produce climate change unprecedented in recorded human history. Such a so-called small nuclear war would reduce food production by 20 to 40% for a decade. Nuclear winter theory was correct. The current arsenal can still produce nuclear winter, and the effects would last for more than a decade. Everything I've told you so far is theory. I've run it in climate models. Now, scientists usually want observations to make sure their theory's right. So chemists do things in test tubes in labs, or physicists have accelerators, but I don't really want to do this experiment, see whether it's right. We've only got one planet. So our laboratory is our computers. But maybe we can observe some things that happen in the real world that inform us about parts of the theory to see whether we have confidence that parts of the theory are right. So that's what we did. We look at analogs. So the seasonal cycle, it gets cold in the winter. Why? There's less sunlight. The sun's tilted, the days are shorter. So we have a gut feeling how much colder it can get if we cut down the sunlight. Day and night, it gets cold at night. Even in an urban heat island, it gets cold at night. So we know that cities can burn, unfortunately, from so-called conventional bombs, incendiary bombs. I don't like the term conventional, it makes it sound like it's okay. And nuclear bombs. I'll get back to that in Tokyo and in Japan and Germany. And then we have examples of the transport of the smoke around the world. We can look at Martian dust storms, and we can look at volcanoes, and we can look at them to see, does it get cold, and forest fires can pump smoke into the atmosphere. So let me show you a couple of those. This is Dresden. This is the Church of Our Lady, which was after the firebombing just before the end of World War II. And Kurt Vonnegut, usually when I was younger, I'd ask my students, how many people have heard of Kurt Vonnegut? Everybody. Now, not very many, but you all have heard of Kurt Vonnegut. He was a prisoner of war in Dresden, and he was trapped underground in prison in a slaughterhouse in a meat locker, and that's how he survived. And he wrote Slaughterhouse 5 about it. It's an amazing book, but it took him 25 years to write it, because he was so traumatized by it. He describes it. This is a picture of, now, the US dropped bombs on Japan, incendiary bombs, before they dropped the bombs on Hiroshima and Nagasaki. Does anybody know how many cities in Japan were burned in the summer of 1945? Summer. How many cities in Japan?
I thought the firebombing of Tokyo was in March.
That's right. So starting then until Hiroshima and Nagasaki, for that period, so maybe it was a little bit more, spring to summer, how many cities were burned? 69.
Wow.
Tokyo was horrible. They painted an X with napalm in the middle of the city, and then more than 300 bombers came in and dropped the incendiary bombs. They decided that precision bombing during the daytime wasn't very precision. They couldn't get the factory. So let's just decide that every house might have a drill press in the back. So they're all war machines. So let's just, with incendiary bombs, you don't have to be precise. You just burn everything. That one night, March 9th to 10th in Tokyo, more people burned to death in 6 hours than any time before or since in the history of the planet. 100,000 people died in Tokyo. It was a huge firestorm. So the deaths in Hiroshima and Nagasaki weren't so many from fires. I was talking about people that burned just from fires. So this is a map of Tokyo. This is the area that burned in Kawasaki, Yokohama, Osaka, Kobe, Nagoya. So in Tokyo, Osaka, and Nagoya, 100 square miles exceeded the areas destroyed in all German cities over 5 years, about 79 square miles. So there was some burning in Japan, in Germany over several years, but this is what Shizuoka looked like afterwards. So I've never heard of it either, but this is one of the 69 cities. And in this book, A Torch to the Enemy, he said, they devastated 178 square miles in 69 cities. Cities are being destroyed at the rate of 4 at a time, with strikes every 2 or 3 days. In 6 months of firebombing, starting with Tokyo, civilian casualties are more than twice as great as the total Japanese military casualties during the whole war. So I think that's genocide. They killed more innocent civilians, men, women, children, than twice as many as all of the soldiers.
Yeah.
So I had this argument with my father. We shouldn't have dropped the bomb. I said we shouldn't have dropped the bombs on Hiroshima and Nagasaki. We should have done a demonstration. Oh no, it stopped the war. It made it shorter. But of course, Japan was about to surrender anyway. And this genocide that was caused in Hiroshima and Nagasaki was already the policy. So it wasn't nothing very different. It's just a bigger bomb. So there's something called the law of war, which you're not supposed to do that anymore. But that was the policy back then. So people have said, okay, so there was all these cities that burned. Did they cause climate change? So in the last couple of months, I've been looking into that, and I'll show you my new results. I just submitted a paper on that. This is the amount of sunlight. So there were a couple stations measuring the amount of sunlight from 1940 to 1952. And this is 1944 and 1945. Was this the effects of the smoke from World War II? There was a reduction of a few tenths of a percent of sunlight.
Where was it being read?
In California and Chile. So the smoke goes up in the atmosphere, it goes around the world, and so it doesn't matter where it's put in. So this is where the observations have errors associated with them, so it's sort of iffy, but anyway, we're suggesting that's what, and this reduction here was caused by pollution, industrialization after the war. Now, then we looked at the temperature, and the black lines are climate model simulations that were done given all the things that caused climate to change in the past, and there was no particular climate change during then, but if you look at the observations, which are these green and orange lines, two different analyses of past temperature, was that the effects of the World War II smoke? 0.2 of a degree Celsius, 0.4 of a degree Fahrenheit, global average cooling over land. So these were La Niñas where the ocean got cold, but there was no La Niña or El Niño there. So we're suggesting that was the effect of the smoke. A small thing, really hard to find. We'll see whether the paper gets accepted or not. Now, Mars has an atmosphere. It's a lot thinner than ours, but it has an atmosphere. And when the Martian Global Surveyor went by, they saw this dust storm being kicked up, and then it was heated by the atmosphere and rose up and ended up covering the whole planet after 3 weeks. The same thing that our model showed the smoke would do. You all know about the asteroid that killed the dinosaurs. Well, the iridium from this, the layers that they found soot with all of them too. And we think that was the fires that was the main thing, because there were pieces of hot rock being shot out from Mexico where it hit around the world and started fires around the world. So that's another example, another analog we can use. This is a forest fire that took place in Yellowstone Park. I took this picture 2007, but 19 years earlier there had been these fires, and I analyzed them. This is Texas, the Midwest. This is the smoke from the fire coming out here, and it ended up covering the Midwest. And I looked at how the temperature would change. In the daytime, it was 6 degrees Celsius, 10 degrees Fahrenheit colder than normal that day under the smoke. So that also shows the effect. And this is light-colored smoke, so if it was thicker smoke, it might have been even more. So now, there's such a thing as called pyrocumulonimbus. If the forest fire is strong enough, it produces its own thunderstorm, and it pumps the soot, smoke right up into the stratosphere. And then you can follow it with satellites. And so there are a few times in the last decade when that has actually happened, and we've observed it. So that process also we've actually observed. This is my favorite painting, The Scream by Edward Munch. I don't know if you know about this. It's painted in 1893, and there were other versions of it. He saw this brilliant sky. The sky is screaming blood and fire, and the scream is from the sky. The person's putting their hands over their ears so they don't hear the scream. They're not screaming. And this reminds me to talk to you about volcanoes, because this was a beautiful sunset was caused by the Krakatoa eruption 10 years earlier that so affected him that he did several paintings based on that sky. This is Oslo, this is the harbor, the city over here. This is the El Chichon volcano in Mexico before its 1982 eruption. This is what it looked like afterwards. And I looked at satellite pictures and followed the dust around the world. This is the Pacific Ocean, it's Hawaii. So in 1 week, each day, in 1 week it got most of the way across the Pacific, in 2 weeks to India, and 3 weeks around the world. So from El Chichon, we learned that if you get the stuff up in the stratosphere, it'll get blown around the world. This is the Laki volcano in Iceland. This is a bus. These are SUVs to give you a scale. And this crack opened up and spewed out stuff for 8 months. And it caused global cooling and a collapse of the monsoons in Africa and India, and it caused famine. Tambora in 1815. This is the volcano that Ronald Reagan was talking about. It erupted. It's the biggest eruption in the last 500 years. And it produced what's called the year without a summer the next year. And Percy Bysshe Shelley and his wife Mary and their friend Lord Byron were having their vacations on the shores of Lake Geneva, but it was so cold and gloomy and rainy they couldn't go out hiking and boating. And they said, well, we're writers, let's have a contest to see who can write the scariest ghost story. And Mary Shelley wrote Frankenstein, inspired by the cold temperatures outside and the monsters climbing over the ice. And it produced movies and even postage. Now, Byron didn't write a book, but he wrote a poem. I learned about this from a Russian scientist when we were working with him in the 1980s, a translation by Turgenev. And it's called Darkness. I had a dream which was not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. And morn came and went and came and brought no day, and men forgot their passions in the dread of this their desolation, and all hearts were chilled into a selfish prayer for light. It was only about 2 degrees Fahrenheit colder because of the year without a summer, so this is poetic license, but it sounds just like nuclear winter. What should we do about it? I'll finish up talking about policy. Carl Sagan was one of the authors of one of the first papers on this, and he was a very good spokesman. And people said to him, you know, don't we need our weapons? How can we get rid of them? And he said, for myself, I would far rather have a world in which the climatic catastrophe cannot happen, independent of the vicissitudes of leaders, institution, and machines. This seems to me to be elementary planetary hygiene as well as elementary patriotism. And I agree. I think elementary planetary hygiene demands that we eliminate nuclear weapons much faster than they're already being eliminated. So what are the policy implications? If we and the Russians immediately get our weapons down to about 200 each, we can prevent nuclear winter. Even if they're used, there wouldn't be enough smoke to cause the temperature to get below freezing, and everybody in the world wouldn't die from starvation. But only nuclear abolition will prevent a nuclear famine, will prevent the effects of smaller numbers being used. I talked to Rose Gottmuller, who is President Obama's nuclear advisor. I said, why doesn't President Obama reduce our arsenal? We can't do that. I said, yes, you can. The treaty that you have, the New START treaty, says the maximum number we can have, not the minimum. Why don't we just reduce them, and it would be a show of goodwill. I mean, we want Iran not to have weapons. How can we expect them to not have them? It's like we're sitting in a bar telling people not to drink. I mean, why would they even listen to us? Oh no, we can't do that. I said, but there's a precedent. George H.W. Bush reduced our arsenals without a treaty when the Soviet Union was coming apart. They wouldn't think like that. It was very frustrating. So how do you feel? Have I really bummed you out? So I'm sorry. It's really been a bummer. Makes you feel bad. So
How about Trump? What is he going to do?
I'll show you. What do you do with this information? So normal psychology tells you that it's when you're presented with something that's really horrible, you pretend you didn't hear it. So denial ain't just a river in Egypt, as Mark Twain said. So, but my reaction is to try and do something about it, not just to try and put it away and figure somebody else will solve the problem. So, I don't know if you know this, biological weapons have been banned. Chemical weapons have been banned. So have landmines, so have cluster munitions, but the worst weapon of all, the nuclear weapons have not been banned. But as Joe said, they're about to be, which is really good news. So the ICAN, the International Campaign to Abolish Nuclear Weapons, has been working on this, and they were able to be very good at politics to get to this point. So first of all, there's a treaty of Tlatelolco, which was signed in Mexico, and it got a Nobel Peace Prize for Alfonso Garcia in 1982. This is a map of the world. All the blue countries are nuclear-free zones. The entire southern hemisphere has no nuclear weapons. The red ones are the 9 nuclear nations, and the yellow ones are ones that are in league with them, like in NATO. But all of Latin America, Mexico, Cuba, no nuclear weapons. So why? Australia could make as many as they wanted. And by the way, this is Kazakhstan, which was devastated by nuclear testing by the Soviets. And they became very anti-nuclear as soon as they got their freedom from the Soviet Union. This is Mongolia. So there are different organizations like Global Zero, ICAN. So this is one of the rockets that the Soviets put into Cuba during the Cuban Missile Crisis. I took this picture in Havana. The exhibit is a replica donated by the Soviet government during the early days of the revolution, the Cuban Revolution. The power of each one had 1 megaton, 77 times more powerful than Hiroshima. There were 36 of these weapons, and we're really lucky that they weren't used. So I had a student from Cuba, and I got an email from him one day. He said, the Cubans want you to come here, talk about climate change. It turned out Fidel Castro had some spare time after he gave up control of the government and found out about my work and invited me down there. So he sat here, that's Fidel, and listened to my talk. And there were like 150 people there. And then they printed out the picture, and he autographed it for me. And then he gave me his autobiography and to practice my Spanish. So I introduced myself in Spanish. And then in his blog the next week, he said, while the United States and Russia each committed to reducing their arsenals to some 2,000 weapons in Prague, the only way to prevent a global climate catastrophe would be by eliminating nuclear weapons. So he got it. Unfortunately, maybe fortunately, he doesn't have any nuclear weapons anymore to get rid of, but there's 9 countries that have them. So they said, can we videotape you? And they showed my talk on nationwide television the next day at prime time. So I was walking around Havana, and I walked into a hotel. There was a TV. I said, and there was a Julia Roberts movie on. And I said, can you change the channel? And there I was giving a lecture. And so what that taught me is you need a movie with Julia Roberts, not a professor giving a lecture, if you want to engage people. So you need this feature film with this beautiful Russian scientist in St. Petersburg and a handsome American scientist in New Jersey, and they're collaborating, and meanwhile along the Kashmiri border. And so you can imagine a plot. If anybody knows anybody that can make a movie, that would be something really good to do. So what have I done? Well, I've done what I can. So I published this paper, Self-Assured Destruction. Most people think it's mutual assured destruction. If country A attacks country B will attack country A, everybody's going to die. But our results show if country A attacks country B and country B doesn't do anything, the climate response to all this smoke is going to kill everybody in country A. So that means if you say you're using nuclear weapons as a deterrent, you're acting as a suicide bomber. It's completely illogical. I was a lead author of the IPCC report. I got a paragraph put in about nuclear winter, so that was the first time that's been in the IPCC report. I don't know if anybody read it, but at least I got it in there. I decided social media is the way to go, so I did a Huffington Post blogs. I did a TED Talk, and I started tweeting. I only tweet about nuclear weapons, not about what I had for breakfast. Last year, we got an op-ed in the New York Times. So that was a big struggle. It turned out Brian Toon and I, who works on this, knew a colleague, Naomi Oreskes, who's a professor at Harvard now of history of science, and she'd had an op-ed, and we said, how'd you do it? She said, oh, I know the name of the editor, write to him, and so he got it in. But just submitting it without that didn't work. So I don't know if anybody read that, but at least we had that in the New York Times. And then the countries of the world that don't have weapons said, this is crazy, let's get rid of them. So they started having 3 conferences on the humanitarian impacts of nuclear war. There was one in Oslo that I went to, one in Mexico that I went to and gave a talk, and one in Austria. And that resulted in the United Nations recommending a conference to negotiate a legally binding instrument to prohibit nuclear weapons. And this passed, and the Security Council can't veto it. The first 5 members of the Security, the 5 members of the Security Council, the permanent members, are the first 5 countries to have nuclear weapons. But they can't veto it. So the first meeting was in March 27th to 31st this year, and the rest, there's going to be 3 weeks starting in June 15th. It's going to end up with a treaty to ban nuclear weapons. Now, the nuclear nations are boycotting it for now, but this will put a huge pressure on them to come to deal with this. And so like 130 nations are involved. So the Pope, before the first meeting, said this conference intends to negotiate a treaty inspired by ethical and moral arguments. It's not beyond our reach. And then this is a picture from the negotiations in March, and I like this. I'm banning nuclear weapons this week. Beat that. And then there's this. Wish you were here. These are the countries, the nuclear. So when Trump got elected, my reaction was to write him a letter, explain to him all the stuff I just told you, and telling him what he could do. So I wrote an open letter to President Trump. And I said, you can change our nuclear policy to one of no first use. You can take the US land-based missiles off hair trigger alert. You can stand down our land-based missiles, begin to dismantle them. And if you do this, they will give you a Nobel Peace Prize. And it's gold, and it's shiny. Wouldn't you like to have one of those? And well, you never know. Nixon went to China and Reagan ended the nuclear arms race, so you never know. But I don't know if he reads though. So, unless someone like you cares a whole awful lot, nothing's going to get better. It's not Dr. Seuss. And I hope we can work to reinforce this ban treaty and get the U.S. to pay attention so our planet looks like this for a long time to come. And if you want more information, you can go to my website. Thanks. Yes.
A show like a CNN or one of the nighttime programs like Colbert or something, they wouldn't be interested in having someone like you on?
We've been trying. We wrote to them. We wrote to Charlie. What?
Rose.
Charlie Rose, and it turns out that I think you've got to have a book, and then they'll put you on. So we're going to write a book based on the work that we're doing now. But no, people don't want to hear about it. They just want to pretend it doesn't exist. So this is the 4th week in a row I've given a version of this talk. Last week I was at the U.S. Capitol giving it to congressional staff. The week before I gave it at the Princeton Plasma Physics Lab. The week before that at a retirement village, Seabrook in New Jersey. So I'm trying to get the word out as best I can. I'm going to be giving a talk at the UN during these negotiations, and a couple guys came to visit me a few days ago. They're going to have me meet with some of the ambassadors at the UN to inform them about it. We're trying to get some language into this treaty that recognizes the climatic consequences, written down. So I'm trying to do the best I can, but if you know of it anyway, if anybody knows Stephen Colbert or somebody like that.
And Amy Goodman.
So Amy, what about Amy Goodman? Well, if you're on a show that's so radical as that, I'm not sure people would pay as much attention as if it was. Well, I know, yeah, everybody here probably would, but
Bill Maher seems to have a good following.
Bill Maher, yeah. So I'd be happy to be on Bill Maher. Yes.
So probably a lot of your colleagues are working on climate change that's a result of the carbon emissions.
Global warming, yeah.
Yeah, and I'm just interested in how do these things intersect, if at all, or how does that conversation go? Because there's several just kind of secondary thoughts I have too that are related.
So
this question.
I'm a climate scientist. I'm using the same climate models that are used for global warming. all the technology, all the wonderful models that have been built by hundreds of people over time, the computers that we use, it's the same people, the same thing. So some people don't want to even work on this. They don't find it interesting, or they think it's too political. Topic is radioactive. Some people say this is really important. When I wrote the paragraph of the IPCC report, they're all reviewed, and so anybody can write in a review, and you have to answer every review. And on this one, some people said, this does not belong in here. This is about humans causing climate change, anthropogenic climate change. It doesn't belong in here. And other people said, it's really important, it should be highlighted. And so we had a meeting of the head of the IPCC came to our chapter and said, I don't think you should put it in there. I said, but Tom, the scoping report, which was the outline written for our chapter, said we're supposed to look at the effects of fires. And he said, well, we meant forest fires. I said, well, didn't say forest fires, just said fires. And this is a human cause of climate change. And so after a discussion, they decided to leave it in. But it wasn't, he said, don't put it in don't feature it so much. So, and there's a related question is, are you doing a graduate student a favor by having them do a dissertation on this? Will they get labeled as some weirdo doing this rather than doing something more mundane? I think that we've got to solve this problem so we have the luxury of worrying about global warming. But I work on global warming too. I work on geoengineering, this idea of putting a cloud up in the stratosphere like volcanoes do to reflect sunlight and cool the earth, which is a pretty bad idea. But I work on that to try and get the benefits and risks if somebody's tempted to do it. So it's.
I'm glad you mentioned that, because I mean, in a weird way, I was thinking like this could,
I didn't show you the slide.
I'm suggesting this, but just simply because it could do what geoengineering, people in geoengineering are talking about.
I have a slide. I didn't show it, but this would solve the global warming problem. There'd be no more CO2 emissions, and it would cool the Earth, and it wouldn't get warm again. But this idea of geoengineering, of flying planes up and spewing particles up, might work. It's never been done, but it wouldn't kill people in the process directly. So it's the same idea. But geoengineering or nuclear war are things that people could do on purpose to cause climate change. Global warming is caused by having these lights on and driving here, and you're not trying to warm the planet, you're trying to cook your food and turn on your lights and doing transport. Now I could give a whole other talk about that, about the solution to that. That can be solved with sun and wind, but if there's a political will to do it. So, but you said you had some other questions, or?
No, I was
okay. Yes, sir.
Yeah, so while this is focused on the nuclear weapon, where are you on nuclear energy, period?
Where am I on nuclear energy? I'm against nuclear energy for a number of reasons. The number one reason is that nuclear energy can make nuclear weapons. So if you refine uranium to burn in a nuclear power plant, then you can also make weapons with it. The spent fuel, the plutonium, can be used to make nuclear weapons. And that's how India and Pakistan, Israel, North Korea got their nuclear weapons, through nuclear power. And so there are theoretically new types of nuclear power which aren't as dangerous, don't produce this radioactive stuff and don't explode like Fukushima or 3 Mile Island, but they don't exist. I think we should do research on it. But we can solve the global warming problem with sun and wind. We don't need nuclear power. It's very expensive. The spent fuel is not inside of this containment vessel. That could be a terrorist target or be released in an accident, an earthquake, like we saw in Fukushima. And so the price of cleaning up Fukushima is greater than the price of building every nuclear power plant in Japan. The price of cleaning up this one accident costs more than the cost of building all the nuclear power plants in Japan. And so I just don't think that for so many reasons. I live near Oyster Creek, which is the oldest nuclear power plant in the United States, in Jersey Shore, and it was licensed for 40 years, and then the 40 years were up to, let's run it for another 20 years. The Nuclear Regulatory Commission says, okay. So that's really scary. They're going to shut it down in a couple years, but it's that technology is not safe, and so I don't think it's a good idea, a solution. Yes?
That's how many weapons, how many bombs each country had. And it started with Israel and said it had 80.
Mhm.
My understanding was Israel had something like 250 to 300 nuclear weapons.
So the question is, how many nuclear weapons does Israel have? Well, if you ask the Israelis, they'll say,
Zero.
yeah, we won't talk about it. We won't admit that we even have them. So my new project, the first thing we're going to do is we're going to go have all these nuclear experts who know about this come, and we're going to design some more credible scenarios of how a nuclear war might be fought, not just 50 Indian, 50 Pakistani, but we're going to include Israel attacking. And they know there's a listing of all the weapons and how many they have. And to best of my knowledge, that's the, I don't know where you got the number 250, but
I read it in a number of places.
okay, well, if it's 80 or 250, it doesn't make much difference, actually. But yeah, so everybody, all the countries except for U.S., Russia, and North Korea have a couple hundred, so couple hundred, and so we're going to outline more credible scenarios. We're going to do detailed modeling of fires in cities and how firestorms work and how much smoke gets up in the atmosphere, and then how the climate responds, and then how agriculture changes. So far, we looked at just the main food crops in China and the U.S., rice, wheat, corn, but nobody cares about rice in China. We're going to do every country, so we're going to say no more chocolate for you, no more wine for you, no more coffee for you, and so people will know how all the crops are going to change and get a better feel for it. And then we're going to look at how the food prices change and put that in an economic model and see how the world food trade reacts, and then how much famine you would get. So we're going to do that for all the different scenarios in much more detail than we ever did before. Yes?
North Korea, could you talk about how much damage we did way back, and should we apologize? But in general, your thoughts about how to talk with Trump about North Korea or the world
How much damage we did about what?
with our bombs way back. I heard we destroyed everything we could find, and then we popped their dams.
Oh, I don't know anything about that.
What are your thoughts about North Korea right now?
It looks like the best thing, I mean, Trump offered to meet Kim, and people thought that was crazy, but that might not be such a bad idea. He really wants legitimacy, and he wants to guarantee we're not going to attack him. So the best deal we can get, I think, is a denuclearized Korean peninsula, where the U.S. removes their weapons from South Korea, North Korea, stops increasing their weapons, no more tests, no more development as a first step, and he gets a meeting with Trump, and that might be a step in the right direction to defuse it. But that's how to organize that and how to get it to work. I mean, I think Bill Clinton went there once to help get some, after he was president, to get some people released. So those are really important. It's pretty scary, though. There's 9 countries in the world with nuclear weapons, and 3 of them have crazy leaders now. So it's really scary. Yeah, us, Russia, and North Korea.
Thank you.